Hi, so we're looking at a circuit today that is very similar to our circuit number 4, where we controlled 8 LEDs. The big difference here is that with our circuit 4, we used 8 pins to control those LEDs. In this example, we're using something called a shift register, which is essentially a serial to parallel converter. So a tiny little circuit, pretty much integrated circuit in this little plastic bit right here. And this allows us to actually only use 3 pins instead of 8, even though we're still controlling 8 lights. So we've got our resistors here connected to each LED. And those are necessary so that we don't provide too much voltage to the LEDs. And then our shift register is actually going to be connected to our power, which we have connected all the way here on our breadboard and then all the way back to the Arduino for 5 volts. So you can see that we also have this connected to our Arduino. So the blue wire is going to pin 2, and then we have the yellow wire going to pin 4, and then the green wire going to pin 3. And so we'll look at what those pins are on our code in just a moment. And then we have the rest of these pins are connected to our LEDs. So here you can see this green one here is connected to this LED. This orange one is connected to this one. This white one is connected to this one. This white one's connected to that one, and so on. So that's why it looks like there's a lot of wires going on, but it's really just connecting each LED to our shift register. So if we look at our code, we've got our serial peripheral interface, and it has the 3 pins, right? We said that there is the data pin, which is on 2, the blue wire, the clock pin, which is on 3, the green wire, and latch pin, which is on 4, the yellow wire. And so we'll look at what these do in our code. So just like with circuit number 4, we have our different functions here, right? So we did the different ways the lights come on. So you have the one after another, ping pong, random LED, marquee, and then the binary count. So we'll look at what those look like. So right now it's doing one after another. So we can see if I start the simulation, they're coming on and turning off one after another. So I just switched it to the ping pong one, so now we can see what that one looks like. So they're going all the way to the end and coming back, so turning on and off and all the way back. So just some different types of lights and how they are being shown. So this is a new code that we see here, the shift right. It's essentially the same thing as digital right, except with this one we're just doing shift right for the shift register, and we are setting it to either high or low so that we can use that in our code. And then the bit right is actually going to allow us to send data to the shift register. So now here we have our shift out, and so this is our data pin, clock pin, and how to use that data, send that data to the shift register. And so the clock line is new, and that's going to be how we move our data in and out of the Arduino quickly. The MSB first is going to be prioritizing the most significant bit first. And then finally we've got our latch pin to make the data appear at the outputs, so the lights, and these are the digital right latch pin high and digital right latch pin low, so to show what the lights are turning on or off. So we'll look at how this looks in each of the codes. So this is the one at a time function right here, and so it's going to be turning the LEDs on and off one at a time. So we've got our delay time, and then down here you can see shift right, high, turn LED on, right? Then delay time, shift right, low, turn LED off, right? So that's just going to be showing us the on and off for that. So the last binary count one is an interesting display. It allows us to see the on and off pattern of the bits. So I'm going to start this so you can see it. So it's 1, 2, 1, 2, 3, 1, 2, 3, 4, right? So they're all adding 1 to each one, right? And doing it again. So here you can kind of see in the code, we've got our shift out, data pin, clock pin, the most prioritized bit first. And then we have the toggling the latch pin high to turn on, and then the latch pin low to turn off, and then adding 1 to data and then repeating it, right? So it's allowing that kind of binary counting aspect to it. So that's it. I hope that this was understandable and kind of helps explain the circuit. Thank you.